So we were having a conversation at this group. We discussed, let's come back together. We discussed two potential options here. What options did we discuss?
Like at the edge.
So they were talking about maybe making it at the edges. Though I'm not really sure which edges would connect together.
No, I meant like the outside circle, like because you said vertices were the vertices of the so like.
Come up here.
Okay, yeah. Like no, like I was just talking about like I meant this, like this little circle, like one.
I see. So this whole circle, thank you. So you're saying this whole circle and this whole circle and this whole circle form a triangular pattern? But if we were actually to define vertices, where would the vertices be?
In the middle?
Okay, so he's talking the middle. Mathematically, what do we call the middle of a circle? So let's talk about the centers of circles. So if we made points for the centers of circles, would that make a triangular pattern?
Yeah.
Now, do we know information about this triangle?
No. We know the radius.
Can you talk with your group? What information can we already start to know about this triangle? Talk with your table. So, can we come back together? Can someone raise your hand and tell me what information do we know about this triangle? I would love to see some new hands. Start me off.
The base of the triangle is the same as the diameter of the spikes.
So he's making the statement that the base of the triangle is the same as the diameter of the pipes. Can someone explain to me why? Does anyone else have the same idea but have a different way of explaining why that is?
Yeah.
Do you want to?
No, I was going to say that you need to have the width of each tube also, because that's not added into the diameter.
Okay, so we know the width of the tube. What is the width of the diameter of the tube? 5 and 6, 10 centimeters. So how does that help us find the equilateral, find this triangle's base? Let's have a conversation here. Yes.
Because one circle is like the radius of the. Yeah, that's the radius.
So how much was this radius? 2 and 8, 10
But
centimeters.
then there's two of those. Yeah, so that equals 6 centimeters.
So then the whole thing is what? 5 and 6, 10 centimeters. So might knowing something about this triangle help us figure out the height of these stacks?
Yeah.
Can we explore that a little more and think about that when we're trying to abstract this a little bit? So keep working and see if that might be helpful information to think about. I want to come back together. So I asked the group to share how they're approaching it, but not to give you too many details so you can kind of figure out your own. But we're still trying to so they're trying to figure out, how do you figure out how much taller it's getting? And they took an approach to how, kind of using some prior knowledge to think about how they can figure it out. Do you want to come in and share? So let's listen carefully.
So what I was doing is this part right here is 2.8, and this part is triangle's equilateral. So this part would be 5.6, and this 90-degree angle. So I just used the Pythagorean theorem: a squared plus b squared plus c squared.
So I'm hoping that his suggestions can give you kind of a hint to work towards a direction that will help you kind of figure out more about the height difference between the stacks of triangles, or the stacks of pipes. So keep working and we'll check back in a little bit.